Alrighty, let's take a look at example 2. Now this is asking for a particular solution, so it's just this question here instead of finding the general. So we need to find the general anyways, so let's take a look. We're given this initial condition where x is 0, y is 1. Find a particular for this equation. So again, you notice you've got all your x's and y's and dy's and dx's mixed together. So the goal here is to get just all your y's and dy's on one side, all your x, dx's on the other. Doesn't matter how you do it. I'm going to move this to the other side. Right? And what you'll get here is negative xy dx. Okay? I still have got x over here, but I'm starting to have y dy, right? And I have a y over here. So I need to move my y to this side. So I'm going to do that because it's being multiplied. I'm going to do that with division, right? Those cancel. And then at the same time, you can also divide this over to the other side. It's going to look a little sloppy, but we'll be left with this on the left-hand side. And we'll be left with negative x divided by e to the negative x squared dx, right? Since we divided. Now, if you notice, we can actually rewrite this to be a little bit easier for us to work with. If this is a negative exponent down here in the denominator, we can go ahead and move it up. So let me rewrite the left-hand side first. We can rewrite this denominator, right, up into the numerator with a positive exponent. So I'm going to keep the negative x times, and then instead of the negative x squared, it'll be e to the positive x squared dx, right? And you don't have to do that, but it definitely makes it a lot easier to integrate, right? Which now we're ready to do. X, y's, dy, xx, dx, okay? So just like we did before, we're going to integrate both sides, like so, right? Okay. And this is, you can try a bunch of different things here about different ways to do it, but I think the easiest way is to just separate this entire fraction into two separate fractions. So if we keep the integration and I pull it apart, so keep y squared over y minus 1 over y dy. So you see all I did was just pull apart this fraction into 2, keeping the denominator. Okay. What that helps me do is now I can integrate these separately. Now, if you notice, this simplifies, right, to just y. So that makes my life a lot easier because what I'll have left is the integral of y minus 1 over y dy. And I like that because I know how to integrate y and I know how to integrate 1 over y. So this integration over here we'll talk about, it's a u sub. So I'm going to run out of space. Let me get some more paper here. Okay, so continuing on, if I integrate y, what I should be getting using our reverse power rule, and if you forget the reverse power rule, it's x n plus 1 over n plus 1, and then the plus c. Now we're going to include the plus c at the end, but that's the reverse power rule here. So if this is y to the first power, we should be getting y, 1 plus 1 is 2 over 2, minus the integral of 1 over y is ln y, right? Okay, so that's the left side. And then when we integrate this right here, this is going back to our exponential, natural exponential function. So we need to do a u sub, where again, the u is our exponent, x squared. So when we take that derivative, du, sorry, I should have done those in a different color, we'll get 2x dx. And if you look back here, well, I've got an x, right? And I have an x here and a dx, an x here and a dx here, right? What I don't have is this 2, Okay, so I need to move the 2 to the other side. Okay. And then we'll worry about this negative at the end, so you can just pull that out. And we're integrating. What I'm going to do is get rid of this x dx right here, this x dx with my 1/2 du, right? So typical u sub, I'm going to put the 1/2 on outside and then the du there. I keep what's in black, my e, but instead of being raised to the x squared, it's being raised to the u, right? Okay, so I'm going to drop all this down. Negative 1/2 integral of e to the u is just itself. So instead, I'm just going to pop back my x squared back where it belongs. Okay, and there's my plus c, right? And so for now, what we have is just the general solution. But we need to have the particular, the specific solution. And remember, this was our initial condition. Y of 0 equals 1. So wherever you see an x, you're plugging in 0. Wherever you see a y, right, you're plugging in 1. Okay, so this becomes 1 squared over 2. And again, if you notice, this is our general solution. So you don't really have to solve for y. Like, you don't need to. This is a totally acceptable general solution. It doesn't have, unless it asks for you in terms of y, don't go through the trouble of isolating y, right? Because that looks like a lot of work, like you noticed in example 1. Oh, that y should be a 1, right? Ln of 1. Instead, x, we're plugging in 0 squared, which is just 0 plus c. And this will allow us to solve for c, right? So ln of 1 is 0. 1 squared is 1. This is 1/2 minus 0 equals e to the 0 is just 1. So that will leave us with negative 1/2 plus c. And when we add to the other side, we'll get 1 equals c. Okay, so that leaves me with my rewriting my final answer as y squared over 2 minus ln y equals negative 1/2 x squared plus 1. And again, doesn't have to be in terms of y. That's an equation. It's completely acceptable. Okay, so that would be the answer for example 2.